So in the last class, we had discussed few examples of 1 mark. Okay. Next, we will be continuing with 2 mark and 3 mark questions on vectors. Okay. Yes. So we have covered this. Okay. So we will continue with the next part. 3D. Yes. Okay. So in the last class also we had covered the questions on definition of vectors, zero vector, then co-initial vector, collinear vector, equal vectors, then negative of a vector. Okay. So these questions we had already covered. Okay. Next, we will proceed with the next questions. So yesterday we have covered the questions on unit vector, 1 mark question, and then okay on the unit vector in the direction of a position vector. So these all questions we have yesterday covered it. Okay. So next today we will discuss the questions for 3 marks. Okay. So 1 mark question we have covered, maximum questions we have covered. Now we will be discussing the question for 3 and 2 marks. Okay. So first I will mention you the concepts. Okay. ಯಾವ concept ಮೇಲೆ question ಬರಬಹುದು ಇಲ್ಲಿ. Okay. So here so pay attention. Okay. So see, for 1 mark we have discussed the questions on types of vectors. Next unit vector. Okay, finding the unit vector, and then finding the direction cosines. Okay. So these are the concepts where the question are occurring from. Okay, for 1 mark. Next, in 2 mark, now we have few concepts here. Because we are getting 2 mark 2 questions. Okay. So for 2 mark we get the question on projection of a vector. Okay, projection of a vector. Next second, checking whether the given vectors are forming a triangle. Okay, what type of triangle it forms. Okay, right angle, obtuse angle, acute angle. And then the third type of question will occur on area of a parallelogram. Okay, it will occur on area of a parallelogram. Okay. Next, after area of a parallelogram, okay, so this is one type, and then a few times the question will occur, has occurred on external and internal division. Okay, so either external or internal. If they are asking, it will be asked for 2 marks. The same question will occur in 3 mark section also. Okay, so most of the time the derivation, okay, okay, for internal division, okay, or position vector of a point of division is asked. Okay, and then same external and internal, if both have been asked, okay, they ask it for 3 marks. And then the next 3 mark question occurs on finding, okay, the dot product of 3 vectors a, b and c. Okay, a, b and c dot product. Based on this the question is occurring, and few questions will occur from a vector product. Okay, vector product. So these are the concepts from where the questions are occurring. So on every concept we will try to discuss two questions. Okay, projection of vector, then area of triangle, okay, area of parallelogram, and all this, and we will try to cover this topic. Okay, so e concepts mele question bandave, and this chapter is very important if you want to score good marks in 2 mark and 3 mark section. Okay, so if you want to score good in 2 mark and 3 mark section, okay, and then okay, we need to solve this. Okay. Yesterday we have discussed the question, and this question I had given you for homework. Show that the vectors are forming the vertices of what a right angle triangle. Okay. So next we will discuss a 3 mark question, that is the derivation. So here we need to show that the position vector of the point P, which divides the line joining the points A and B, having position vectors A and B internally in the ratio m is to n. Okay, internally in the ratio m is to n. So this 3 mark derivation has occurred 2 to 3 times in the board exam. So we will discuss the proof for this. Okay, is the video, whatever the screen I have shared, is it visible, students? Is the screen visible? No problem with the file I have shared. Okay. Yes. So we'll continue with the derivation of this. We'll discuss the proof for this. Okay. 1 minute. So see, pay attention here. So first we will consider the figure for this, and then discuss the derivation. Okay. So the derivation is very simple. Okay, just we need to consider first 2 points. Okay, we need to consider 2 points joining the so PQ. Okay, are the 2 points. Okay, and then we need to consider the origin. Okay, consider the origin. Okay, so from O you need to join P. Okay, and then you need to join Q. Okay, so this way will be the position vector A, and this will be the position vector B, and then one more point we need to consider, that is R. Okay, the position vector R, we are considering the okay magnitude PR m. Okay, and then this we are considering it as n. Okay, so this is the figure we are using to prove it, and the position vector of the point R, we are considering it as vector R. Okay, we are considering it as what, vector R. Okay, so we'll discuss the solution. Okay, for this, so in the solution what we need to consider is let P and Q. Okay, so let the position vectors of P and Q be what? Vector A and what? Vector B. And R divides the line, the vector PQ. Okay, the vector PQ internally in ratio m is to n. Okay, so here what we are doing is let R be a point on the line PQ. You can consider directly. Let R be the what? Point on PQ, okay, uh, which divides PQ, which divides PQ internally, okay, in ratio m is to n. Okay, m is to n. Okay. Now see from the figure, just we need to mention the position vectors of the point P, of the point Q, and the point R. Okay. So see from the figure, we are considering OP. The position vector OP is equal to what, vector A. Next OQ is equal to vector B. Okay, and then OR, okay, is equal to vector R. Okay, vector R. Okay, and then now see, from the given figure we are considering the modulus value. Okay, see the modulus value of what, so PR. Okay, see PR upon RQ. Okay, PR upon RQ will be equal to what, it will be equal to E vector M divided by sorry, M is to N. The ratio is, and the ratio of the magnitude of these two vectors is what, M upon N. So we are considering this as m upon n. Okay, m upon n. Next, we will cross multiplied, so it will be n into PR. Okay, is equal to m into what, RQ. Okay, so this will be n into, so PR can be written as OR minus what, OP. Okay, and this will be equal to m into OQ minus what, OR. Okay, OQ minus OR. So next we are substituting the values of these position vectors of OR. So position vector of OR is what, vector R. Okay, so this is vector R minus OP. See the position vector is A. This will be equal to M into OQ, it is B, minus OR, again it is equal to R. Okay, so on simplifying we get, see, NR, okay, minus NA, okay, is equal to MB minus what, MR. Okay, so collect the R containing terms on one side, so we get MR plus what, NR is equal to M into vector B plus N into vector A. Okay, so by taking out vector R as common, we get M into N is equal to M into vector B plus N into vector A, or the position vector R, the value of position vector R will be MB NA bar divided by M plus N. Okay, so this is the value of R. Okay, and this gives us the value of the position vector R, which is dividing the line joining what, PQ. Okay, so this formula we are using to calculate the position vector R of the point of division. So this is the point of division. So point of division position vector can be calculated by using the formula R is equal to M into vector B plus N into vector A divided by M plus N. Okay, divided by M plus N. Okay, so this is the derivation. So in the derivation, first the figure is very important. 1 mark will be given for the figure. Next for description, and then simplification. Okay, so based on the figure, just we are writing the description. Let R be the point on what, PQ, which divides PQ internally in the ratio M is to N, and then let the position vectors of what, OP be A, OQ be B, and OR be what, R respectively. Okay, and then from the figure we can write. Okay, from the figure PR upon RQ will be equal to what, M upon N, and then rest part is simplification. Okay, hope you have understood the derivation. So now based on this derivation, okay, see the same formula, whatever the formula we have written here, the same formula with negative sign we are using for external division. So it will be M into vector B minus N into vector A divided by what, M minus N. Okay, so here they have already told the point R is dividing internally. Okay, so if the point R is dividing externally, the same formula is used. with negative sign. So it will be m into vector b minus n into vector a divided by what? M minus n. Okay. Next, we will discuss the next part, the question based on this. Okay, so we will discuss the question based on this. So either the question will be asked for 2 marks or for 3 marks. So if they ask only the internal division, it will be asked for 2 marks. Okay. And if they ask both internal and external point, then it will be asked for 3 marks. Okay. So we'll discuss it. Okay. So see here, the given question is find the position vector of R which divides the line joining 2 points P and Q, whose position vectors are what? I cap plus 2j cap minus k cap and minus I cap plus j cap plus k cap respectively in the ratio 2:1 internally and what? Externally. Internally and externally. Okay. So here both we need to calculate. First we need to calculate the position vector of the R which divides it internally, and then we have to calculate the position vector R when it is dividing the same line externally. Okay, same line externally. Okay, so we'll discuss the solution for this. So in the solution part, first we need to write down the formula and the position vectors. So see here the position vector C of the point P is nothing but I cap plus 2j cap. So we can write OP. So to use the formula, we can use OP is equal to A is equal to what? I cap plus 2j cap plus k cap. And then see OQ is equal to vector B, okay, which is equal to minus I cap plus j cap plus what? K cap. Okay. And the ratio given, the ratio here is 2:1. Okay. So first we will write down. Okay. We will calculate the position vector of R for internal division. Okay. So see position vector. Okay, of R. Okay. Position vector of R, which divides what? Which divides the vector joining PQ in the ratio. In the ratio over here is 2:1. Okay, 2:1 internally. Internally is okay. So here we have R is equal to M into vector V plus N into vector A divided by what? M plus N. So we will substitute the values. So R into, see the value of M is 2. Okay, so it will be 2 into vector B, already it's given I cap plus j cap plus k cap, and then N into the value of N is 1 into, so 1 into A value is I plus what? 2j minus k whole divided by m plus n. So m plus n is 2 plus 1. Okay. So on simplifying it further, we get so we get 2 I cap plus what? 2 j cap 2 k cap, and then plus, okay, I cap plus 2 j cap minus k cap whole divided by what? 3. Okay. So on simplifying it further, just simplify the I components. 2I plus I, it will be minus I. Next 2j plus 2j, it will be equal to 4j, and 2k minus k, it will be equal to k whole divided by what? 3. Okay, so this is the first part. Similarly, we need to calculate for external division. Okay, so when the point R divides it externally, what will be the value? So see, when the point R, okay, when the point R, okay, divides PQ externally, okay, externally in 2:1. Okay, so when it is dividing externally in 2:1, so we are using the same formula but with negative sign. So it will be m into vector b minus n into vector a divided by what? M minus n. So same formula we are applying here. same substitution. So 2 into I cap j cap plus what k cap plus 1 into I cap 2 j cap minus k cap all divided by 2 plus 2 minus 1. Okay, so it will be equal to minus 1. So I'm simplifying. See, further I will do it directly now. So see 2 I cap minus 1 I cap, it will be, here we need to use negative sign. Here we are making use of a negative sign. Okay, so on simplifying, so see what do we get? So minus 2 minus I, it will be minus 3 I cap. Okay, and then j minus 2j, it will be j minus 2j will be minus j. Okay, and k minus minus of minus, it will be plus k. Okay, so see 2 we need to multiply it. 1 minute. So j and j will cancel. So it will be plus j minus 2j, it will be 0. Okay. If you want, you can do one step extra, or directly also you can do it. No problem. So this will be minus 3 I cap. See, here 2 into j, it will be 2j, and then minus 2j, it will be 0. And then we will be getting k minus of minus, it will be plus. So it will be equal to what? 3k divided by 1. Okay, divided by 1. So the final answer will be minus 3 I cap, 3 j cap. So this is the first equation and this is the second equation. So as per the question, they have asked us to calculate first internally and then calculate the point of what this position vector of the point of division externally. Okay, so both the ways we have calculated. So this question has also occurred a few times in the board exam. Okay, in the board exam. Okay, next, based on this, there is one more question, that is midpoint. Sometimes this question is asked for 2 marks. Okay, so for midpoint, what we need to do is same formula we have to use. Okay, so when they are asking us to calculate the midpoint, okay, they are asking us to calculate the midpoint or the position vector of the midpoint, then R is equal to, it will be just A plus B upon 2. Okay, because when we are considering the midpoint, the ratio M is to N will be equal to what? 1 is to 1. Okay, the ratio M is to N will be equal to 1 is to 1. So R will be equal to A plus B upon 2. Okay, so sometimes for 2 marks they ask calculate the midpoint of the line joining PQ. So there we are using R is equal to A plus B upon 2. Okay, next. Okay, so the next example, so this is a 2 mark example. The we need to calculate, find the angle between the vectors. Okay, so we need to calculate the angle between the vectors. So we can calculate the angle between the vectors in 2 ways, either by using the dot product or by using the cross product. Okay, so here we will be making use of the dot product and calculating the angle between the two vectors. Okay, so you need to know the formula for what? Dot product of two vectors. The formula for dot product of two vectors is dot product of two vectors. See, vector A dot vector B will be equal to mod of vector A into mod of what? Vector B into cos theta. Okay, so mod of vector A, mod of vector B into cos theta. Or from the same formula we can get the angle between two vectors is equal to cos theta is equal to what? A dot B. Okay, vector A dot vector B divided by mod of vector A into what? Mod of vector B. Okay, A dot B will be equal to cos theta will be equal to A dot B divided by mod of A into mod of B. Okay, so here we will consider this formula and try to calculate the angle between the two given vectors. So see, in the solution we are considering the two vectors as vector A is equal to 2i minus 2j plus k, and vector B equal to 2i minus j minus 2k. Okay, 2I minus j minus 2k. Okay, so here cos theta will be equal to cos theta will be equal to. So we are taking the dot product of these two vectors. So 2 into 2, okay, plus minus 2 into minus 1, and then 1 into minus 2, okay, 1 into minus 2 divided by root of, okay, root of mod of vector a will be 2 square is 4 plus 4 plus 1, okay, and into mod of vector b, again it will be 4 plus 1 and 4. So on simplifying it further, we get 4 plus 2, okay, 4 plus 2 and minus 2 divided by root of 9, and root of 9 it will be 3 into 3, okay, 3 into 3, so it will be equal to 4 upon 9, okay, the value will be equal to 4 upon 9. This is cos theta. So the angle, the final angle will be cos theta will be equal to 4 by 9, or theta will be equal to cos inverse 4 by 9, okay. So theta will be equal to cos inverse 4 by 9, okay. So this will be the value of angle between the two vectors, that is theta, okay. So in some cases they will give directly the mod value. So in some examples they will give mod a and mod b values, okay, mod a and mod b values is given, and they are asking us to calculate the value of the given that is angle, okay, and also they will give a dot b value. Okay, so these three values are given. So when these three values are given, see one simple example I will give you. So see a dot b is equal to what? 15. Okay, is equal to 15. A dot b is equal to, I'll take it as root 6. Sorry, root 6. And see mod of vector a, I will take it as root 3, and mod of vector b, I will take it as 2. Then what will be the angle? Just tell me the values. Try to calculate this. I'll give you 1 minute time. Try to simplify. See, a dot b is root 6. Determinant, the modulus value of a is root 3. Mod b is root 2. Then cos theta is equal to. So make use of the same formula, and then try to calculate what is the value of cos theta. What is the value of cos theta? I'll give you 1 minute time. Try to simplify and tell me the answer. What will be cos theta? Okay, did you all get the answer? What What will be the answer? Students, what will be cos theta value? Cos theta, or what will be the angle theta? Just type it in the chat box if you have obtained the answer. And then we will discuss the next question. Be quick. Yes, be quick, students. Tell me what will be the answer for this. Yes, one of you have replied. Okay. 25 by 18. Just check it once again. You will get a direct answer there. Okay, you will get a direct answer. Because see, A dot B is root 6. Okay, A dot B is root 6. Okay, A dot B is root 6. Very easy. See, A dot B is root 6 there. Simple direct value you will get. Check it. Not 3. Okay. See, pay attention here. I will simplify it. Vedvati. See, cos theta will be equal to. See, cos theta is equal to, we know the formula. A dot B, it is given as root 6. Okay. Mod of A is 3 and mod of B is what? 2. Okay. So this root 6, I can write it as 3 into what 2, and this is root 3 upon what 2. Okay. So you can write it as root 3 into root 2 divided by root 3, and 2 can be written as root 2 into what? Root 2. So 1 root 2 root 2 root 3 will cancel. The value will be what? 1 by root 2. Or when you simplify, see the final step, what do we get here? Theta will be equal to what? Cos inverse 1 by root 2. Okay, so cos inverse 1 by root 2 is equal to what? 45 degree. So theta will be equal to what? 45 degree. Okay, theta is equal to 45 degree. Okay, theta is equal to 45 degree. Okay, so this is the value. Theta is equal to 45 degree. Okay, so check where you have done the mistake. Okay, and practice such examples again are occurring for 2 marks. So next we will be discussing the very important one. So again, this question has occurred maximum times in the board exam. Find the projection of vector I cap plus 3 j cap plus 7 k cap on the vector 7 I cap minus j cap plus 8 k cap. Okay, so projection of a vector on another vector. Okay, so here we have a direct formula. Okay, so there is a direct formula to calculate what? A projection of a vector on another vector. Okay, hope you know the formula. Anybody? Projection of a vector on another vector. What is the formula for projection of a vector on another vector? Be quick. Any one of you can answer it. We'll continue with the discussion. So, or dot product of two vectors. Okay. So this question is occurring from dot product of two vectors. So there is a formula. The projection of what? The projection of vector A on B. Okay, so if they are asking vector A on B, then it will be A dot B dot product. So since on B we need to calculate, so it will be divided by B. Okay, same way if A B on A is asked, again A dot B divided by A will be the value. Okay, divided by S Vedavati. Okay, so vector B, A on vector B will be A dot B upon mod of vector B. So simple here, two vectors are given. So the first vector I will consider it as vector A. This I will be considering it as what? Vector B. So see, using this we will simplify it. So directly A dot B, see it will be 1 into what? 7. Okay, plus 3 into minus 1 plus 7 into 8. Okay, whole divided by mod of vector b. What will be the mod of vector b? Modulus value of vector b, it will be square root of, okay, square root of 7 square is 49, minus 1 square is 1, and 8 square is 64. Okay, so on simplifying, we get 7 minus 3 plus 7 into 8 is 56. Okay, whole divided by 50 plus 64, it will be root of, okay, see 50 plus 60, 114, it will be divided by 114, and 7 minus 3 is 4, it will be 60. Okay, so this will be 60 divided by root 114 will be the answer. Okay, so 60 divided by root 114 will be the answer. So projection of vector A on vector B. Okay, so such examples have been asked repeatedly. So practice this example, projection of vector. Okay, so whatever the concepts we have discussed, based on that we have covered the question on internal and external division. Next we have covered the question on projection. Okay, and then we have covered the question on dot product of two vectors. Okay, so few more questions on cross product of two vectors we will be discussing. That is area of parallelogram. Okay, and then area of triangles and all. Okay, so we will discuss that question. Yes. So an important question. So this question has been asked for 3 marks. Okay, 3 mark. The question is, if A, B, C are unit vectors. Okay, so if A, B, and C are unit vectors, and A plus B plus C is equal to what? 0. Okay, A plus B plus C is equal to 0. Find the value of A dot B plus B dot C plus what? C dot A. Okay, so this question is been asked, okay, for 2 marks actually. The next question has occurred for 3 marks. Okay, so see, pay attention. How we can simplify it. So given part, first we are writing the given part. So here, see, mod of vector A. Okay, mod of vector A is equal to 1 because it is unit vector. Mod of vector B is also equal to 1, and mod of vector C is also equal to what? 1, because they are unit vectors. Okay, and another hint is given. What is the hint given? Vector A plus what? Vector B plus vector C is equal to what? 0 vector. Okay, it is equal to 0 vector. Okay, and since it is equal to 0 vector, the square of a vector, okay, if we square this, this will also be equal to what? 0 square, it will be equal to 0. Now see, here what we are doing is we are applying the formula for A plus B plus C whole square. Okay, with the modulus sign, with the modulus values. Okay, so this will be equal to, see, mod of vector A square, next mod of vector B square plus mod of what? Vector C square, which will be equal plus 2 into, okay, 2 into, it will be A dot B plus what? B dot A and C dot A. Okay, C dot A. Okay, so this is the formula. This is just the expansion of A plus B plus C whole square, and this is equal to what? 0. So now see, now mod A is equal to 1. Okay, so square of mod A will also be equal to 1. So this will be equal to 1, 1, and again 1, and then 2 times. Okay, 2 times. See, A dot B, B dot C, and C dot A we need to calculate. We'll keep it as it is. A dot B, B dot A, and what? C dot A is equal to what? 0. So see, this sum of these will be equal to 3. Okay, so it will be 2 with the same bracket A dot B, B dot A plus what? C dot A, which is equal to minus 3. Or on simplifying it further, we get A dot B plus B dot A plus C dot A is equal to minus 3 by 2. Okay, it is equal to minus 3 by 2 is the value. Okay, next. So the same formula we are using to solve the next question. So you need to remember this expansion of a plus b plus c whole square is equal to mod a square plus mod b square plus mod c square plus 2 times a dot b plus b dot a plus c dot a is equal to here 0 because the value is already given. The condition is given a plus b plus c is equal to 0. Okay. So next we will discuss one more similar question. Uh, Okay. So a similar question is given. Okay. So in this case, three vectors A, B, C satisfies the condition A plus C is equal to 0. Evaluate quantity mu is equal to A dot B plus B dot C plus what? C dot A. If mod A is equal to 1, mod B, mod of B, vector B is equal to 4 and mod of vector C is equal to 2. Okay, so mu is equal to C. Again, same thing we need to okay, apply the same formula we need to apply and calculate the value of mu. Okay, we need to calculate the value of mu. Okay, so again we are using the same formula what we have used for the previous one. So here as in condition, so over here what the values of A, B, and C, the modulus values are different in the previous case. All the vectors were unit vectors, but here, see, one of the vector magnitude is 1, other vector the magnitude is 4, and magnitude of C is 2. Okay, so we need to find out C. A plus B plus C is equal to 0. Again, the same condition we are using. Vector A plus what? Vector B plus vector C is equal to 0. So mod of these will be okay. Mod of vector A plus vector B plus vector C will also be equal to 0, or square of this will also be equal to 0. So we are squaring it on both the sides. Okay. So this will be 0. Or on simplifying it further, we get mod A square plus mod B square plus mod C square plus 2 times. Okay, it will be A dot B plus what B dot A plus C dot A is equal to 0. Okay, so here I will write the terms directly. 1 square 1 4 square, it will be equal to 16, and then say 2 square is equal to 4 plus 2 times. Okay, we need to calculate this value. A dot B plus B dot A plus C dot A is equal to what? 0. So this will be equal to 2 times A dot B B dot A C dot A B dot C, not A, B dot C. Okay, B dot C. So this will be equal to C. 16 plus 4 is 20, 21. Okay, so this will be minus 21. Okay, it will be equal to minus 21. And then on simplifying, we get A dot B plus B dot C plus C dot A is equal to minus 21 upon 2. Or on simplifying further, we get mu is equal to minus 21 upon 2. Okay, so we have discussed these questions. Both the questions are similar. Okay, so again, practice some more questions on these type. Okay, and then the next question, you all take it for homework. Okay, you all take it for homework. Try to solve it for homework. Okay, so here they are asking us to calculate the unit vector. Okay, find the unit vector perpendicular to vector A and vector B. Okay, perpendicular to vector A and vector B. Okay, so this question is also important here. It is occurring from cross product of two vectors now. Okay, cross product of two vectors. So we need to calculate the vector which is perpendicular to the given vectors. Okay, the vector which is perpendicular to the given vectors. So here what we need to do is, okay, so you find a unit vector perpendicular to both what A and B. Okay, perpendicular to both the vectors what A and B. So whenever such questions are occurring, that is perpendicular vectors, always we need to use the cross product of two vectors. Okay, because when we use the form, see when we have come across, if you have come across the formula of A cross B, okay, vector A cross what vector B will be equal to what mod A mod B, okay, mod A mod B sine theta into what n cap. Okay, so this n cap is nothing but the unit vector which is perpendicular to both the vectors A and B. Okay, this n cap use the direction which is perpendicular to both the vectors. So here we are using the same formula. So by using this formula, the unit perpendicular vector, I will be writing the formula here. Unit perpendicular vector to what vector A and what vector B is equal to, say, A cross B divided by a mod of A cross B. Okay, so this is the unit perpendicular vector which is perpendicular to these two. Okay, so A cross B divided by what mod of A cross B. So A cross B, you all know how to calculate it. We need to take the determinant of these two and then take the modulus value. Substitute in the formula A cross B upon mod of A cross B. You will get the unit vector which is perpendicular to the two vectors A and B. Okay, so we will stop the class here today, and remaining few examples we will continue tomorrow. Okay, and take care. Bye.